Welcome viewers. In this video we'll see the types of relation available in sets, relation and function, one of the topic in mathematics. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, the types of relation. First one is the reflective. A relation R on a set A is said to be reflective if every element of A is related to itself, right? The relation R, we are checking the relation R for a set A. Every element of set A is related to itself. There is a relation. There is a relation between all the elements in the A. Then it is called a reflective, right? This, every element of A is related to itself. There is a relation between all the elements. Then the relation is called a reflective. Symmetry. A relation R on a set A is said to be symmetric if A comma B epsilon R implies B comma A epsilon R, right? AB as well as BA both are implies for all AB epsilon A, right? A comma B means is related to R means B comma A related to R means AB also related to A, right? This AB is the subsets that is related to A. Then it's called a symmetry. AB, BA, then AB is belongs to AB epsilon A. It's called a symmetry. Then transitive. A relation R. A relation R is R on a set A is said to be transitive if A comma B epsilon R and B comma C epsilon R and A comma C epsilon R for all A B C epsilon A, right? We are checking the relation R for a set A, AB epsilon R, BC epsilon R, AC epsilon R, right? A and B is combined here, B and C is combined here, A and C is combined here. All are implies to R means all ABC epsilon A, right? This ABC R belongs to the A. That's called a transitive. AB, BC, AC. So that ABC implies the A. It's called a transitive. Anti-symmetry. A relation on R, the relation R on a set A is said to be anti-symmetric if A comma B epsilon R and B comma A epsilon R, that is implies A equal to B for all A comma B epsilon A, right? It's called a anti-symmetry. Symmetric means it is only AB epsilon A, but here A equal to B. This is said to be anti-symmetry. The relation on A R for a set A, AB epsilon R, BA epsilon R and also A equal to B for all A comma B comma A comma B epsilon A. Then it is called a anti-symmetry, right? Next we will see the equivalent. We will see another two more types available. Equivalent. A relation R on a set A is said to be equivalent relation if it is reflective, symmetric and transitive. So what we discussed earlier, three relation, if the relation on R on a set A satisfy reflective property, symmetric property and transitive property, then it is called a equivalent set. The relation is equivalent, right? By satisfying reflective. Reflective means all the elements related to itself. Symmetric means A comma B epsilon A. Transitive means A comma B comma C epsilon A, right? All are related. A comma B is related, B comma C related, A comma C is related. If you satisfy all, it is called a equivalent. Then function. A function f from a set A to be set B is rule which assign each element of A is element of A unique element of B, right? So the A element, if we are checking from set A to set B, each element of A is a unique element of B. Then it is called a function. If f such that A to B, then A is a domain, B is the codomain, right? So this is a function A to B. Then it is called A is the domain, B is the codomain. So in this video we discuss about the types of relation available in the sets, relation and function. First type is reflective, that is related, all the elements are related. Symmetric, A comma B and B comma A all are symmetric. Transitive, three elements are available, A comma B, B comma C, C comma A all are transitive. Antisymmetric, same thing, similar to symmetric, but it is A equal to B, A comma B, B comma C and A equal to B. Then equivalent, if we satisfy reflective, symmetric and transitive, that is called a equivalent relation. Then we discuss the function f. If f such that A to B means A is a domain, B is a codomain. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.